Rich Metters, I'm from the business school. As Alex calls me, the logistics dude. Also, my end of the business school deals with manufacturing, the actual making of stuff, the transporting of stuff back and forth. So you might wonder, what does research in manufacturing and logistics look like? Largely, we take what's in the world, reduce it to mathematical symbols, and we do a lot of math. Math, math, math is what we do. But in getting out in the world, I find that if you have employees that look like this, or employees that look like that, all these nice mathematical formulas that I have published many of in my day, just really don't apply anymore. We come up with solutions that are wrong, or simply cannot be implemented in the cultures in which you have Orthodox Jews, or the cultures where you have predominantly Islamic aspects to it. And a lot of other different religions impinge upon these mathematical models that we've been dealing with in the business school. So, I have a dabbling knowledge of a variety of religions. I've collected about 25 anecdotes or so. But what I'm after is somebody who knows religion better than I am to help me focus my work.
Wow, less than 2 minutes. Great.
So I'm an assistant professor from Department of Agricultural Economics. So my proposed research is to combine the conventional consumer research methods with neurophysiological methods. So the conventional consumer research methods like consumer willingness to pay, they typically relied on self-reported measurements such as willingness to pay. And so many research, for example, some of our research found that consumers are willing to pay, the US consumers they are willing to pay more for the US products compared to the foreign products. However, a 2016 AP poll showed that US consumers actually, they prefer to purchase the cheaper foreign products, even though they value the domestic products more, right? So then it would be interesting to look at some of the neurophysiological measurements, such as like brainwave and the eye checks, to look at the consumer preference more objectively. And some of our research also find that even though consumers are willing to pay more for their US products, willing to pay less, value less for their Chinese product, but we found that their frontal asymmetry index, which is an indication for their purchasing preferences, shows that they prefer the US products more, right? So that's my proposed research, and some potentially interesting questions will be, so currently we do see an increasing trend for US imports for foreign fresh produce. And also there are some, like in China, now China open up the imports for US beef and US rice, right? So it will be really interesting to look at those questions. Yeah.
Thank you. Michael Polymenis.
Hello, I'm in the Department of Biochemistry and Biophysics. It's AgriLife.
So, the microphone is right here. If you come a little closer, he will appreciate it, I'm sure.
Okay. So, I like to walk. All right, so what I work on is the coordination of growth and division. Cells, the unit of life, usually have to grow before they can divide. We heard about the business school earlier. So where cells like to put their resources is to make machines that make proteins, the ribosomes. And if food is not around or it's not plentiful, they have fewer of those machines. But the idea then is that how does that change gene expression in the cell? The targets are not known. I work with a model organism, yeast. We know how to find these targets. We've applied this technology in some settings. We've published these results. We can find where the ribosomes bind to, which messenger RNAs, isolate those, sequence them, and we have all the technology to analyze them. Here, I propose to apply this technology at different growth conditions, different growth rates in very precise settings that we use. And what I'm looking for are other kinds of cells. So yeah, maybe try a different model system. If whatever is your favorite cellular system, if that grows at different growth conditions, then we can sample it and we can analyze it, and ideally also improve our computational approaches in this. We are end users. We have not developed our own tools. If you can come up with better ideas to analyze this complex data, that will help. I guess I have a few more seconds, so, but basically that's the plan. I mean, we work with this beast that's budding yeast, brewer's yeast. It can grow precisely in fermenters. Your system doesn't have to grow in fermenters. We use it because we can. It's very precise, but it doesn't have to be. Then we isolate the cells at different growth rates, sequence them, generate these specific libraries that tell us where the ribosomes bind to, and then we do our functional analysis in yeast. So please suggest your favorite model system. Thank you.
Howdy. So while we sit here, about 2.5 million people are actually in prisons in the United States. And out of these 2.5 million people, approximately 500,000 people are juveniles. And out of these juveniles, about 300,000 kids will never see the light of day because they are pretty much in life imprisonment. There's obviously something going on which we as a country that can launch robotic missions to 1 trillion miles away, yet we cannot solve this fundamental issue of why are we having this much of criminality in the United States. This is something that we can, as Americans, we should be honestly ashamed about. And the prison system is the fastest growing business in the United States. So my proposal is to actually question the paradigm. Can we change the microbiome and cause an effect in behavior and criminal behavior? The hypothesis for this is very tantalizing because we see all the data sets that are coming out showing microbes control behavior, autism, personality, etc. But nobody wants to go into what I like to call the $1 million, $1 trillion gorilla in the room. Can it actually be responsible for criminal behavior? Because if we do that, if we can find out that we can modulate the microbiome, be it by antimicrobials, be it by diet, whatever, we possibly would create a paradigm shift in society. And there are obviously a lot of vested interests against it. If you can remember back in the 80s with Helicobacter pylori, when the scientists said it was a microbe that was causing it, but the drug industry was not willing to go forward with it. So what I want to propose in this study, and that's interest from the Houston Police Department, is to actually understand, collect the samples, fecal samples from prisoners and from a control group, and actually use deep sequencing and bioinformatic tools to understand what's in these feces, because 20% of all prison inmates come back into prison because of recidivism. There's something that we can understand with new genomics that I'm hoping that we can get partners from this tremendous university to answer this question. So, thank you.
Thank you. Okay, our next speaker is Stephanie Payne. Give you a few more seconds.
Okay. Hi, I'm Stephanie Payne from the Psychology Department at Texas A&M. And I'm presenting today in collaboration with my colleague, Benny Holland, who's over here. He's the director of the Clinical Learning Resource Center at the Health Science Center and holds a non-tenure track position. So we're looking for 2 tenure-track colleagues with related experience and expertise to propose a study. To tell you a little bit about the background, each year there are approximately 1.5 million medication administration errors, costing billions of dollars and thousands of deaths. A large majority of these medication administration errors go unreported, precluding the opportunity to identify the root cause for those errors and for remediation and improved patient safety. Even though all health professions recognize the ethical and moral responsibility to report, disclose, and discuss these errors, the rate of actually doing so remains woefully low. Barriers to reporting and disclosing errors include a wide range of individual and systematic issues, including a lack of self-efficacy or confidence in one's ability to disclose the error. Clinical simulation has been shown to be effective methodologically for training medical skills, procedures, communication, and teamwork. In this T3 project, we propose that clinical simulation can be used to facilitate reporting and disclosing of errors, and will enhance health professionals' students, particularly, self-efficacy and intentions to engage in these behaviors when necessary. We propose to design and implement an online anonymous incident reporting system and make it available to Texas A&M health professional students, alumni, and health professionals in the area. The database will provide data on errors for education and research purposes. In addition, students will simulate the disclosure and reporting of medication errors to a standardized patient or family member, and then participate in an interprofessional conference to discuss the root cause and potential changes needed to avoid future incidents. Surveys and subject matter expert observational ratings will be used to provide data to evaluate the effectiveness of this intervention. Thank you.
Go ahead. Yeah, I go by Alex, by the way. Howdy. Hopefully I can find the mouse here. So how do we solve the food scarcity problem when our population will go to 9.5 billion by 2050, by 2050, and probably will not stop growing before it plateaus around the year 2100, maybe 11 to 12 billion. One of the main tools that we have in the tool chest is what's called precision agriculture, which is a method of optimization of farm production, whereby you use data and analysis tools, and I use the term mechatronics, but basically it is an automated means of applying the decisions that you've made through your data and analytics to appropriately apply your inputs on a small scale rather than on entire fields. Some of the pictures I have here, the few up at the top, show a cotton harvester with sensors and GPS on it that enable you to produce a map like you see kind of on the upper right middle there. That's a yield map of cotton. That is data that enables decisions to be made. On the far left, you see a color infrared image that was taken from a drone over a cotton field that shows you that we now have the capability to measure things on an individual plant level. The harvester at the bottom left gives you an indication of new technology that have many, many sensors implemented on them. These sensors are pushing data to the cloud, so there is lots and lots of data that's being collected on farming operations these days. The big problem that we have is, on irrigated farms, the most important input that we have is water. We currently don't have the capability to apply water precisely. The very best case scenario is like the map on the right that shows the different colors there. You can implement something like that on a very expensive center pivot system so that you might be able to irrigate a few thousand plants at a time precisely. But I'm done. My 2 minutes went quickly. The last comment I would make is that I'm proposing a means to do single plant application of water through optical control of microfluidics. Thanks.
So we live in Texas where the half of the commodity is in beef. So our project is focusing on the beef industry and namely on the combination of 3 cutting-edge technologies that we developed: our higher volume bioaerosol sampling capability, our odor-based sensing of pathogens, and our HVAC pattern-based airflow pattern modeling and computational modeling of the airflows in different facilities. So using our higher volume wetted wall cyclone collectors, we are able to sample the spatial and temporal distribution of pathogens at facilities in large air volumes. Exploiting the odor-based sensing, we can use sensors that can tell us what kind of pathogens are present in these samples and in these facilities. And finally, if we use this odor-based speciation and identification of bacteria coupled with our higher volume bioaerosol sampling that enables the tracking of the pathogens all over the facilities where the animals are being processed, we can optimize the HVAC airflow patterns that will prevent the spread of these pathogens and that will improve the sanitation of the facility and with that the sanitation of the food that we are consuming. And this is just an image of how we would combine all these 3 technologies: the wetted wall cyclone collectors, the odor-based spectra, and the HVAC pattern-based flow pattern optimization. And altogether, this will go back to the facilities where large numbers of animals are kept and basically improves the sanitation of the facility, of the air, and with that of the food that's being processed at the facilities and being sold to the public. This way, we can reduce the number of casualties and the number of diseases every year that is linked to the beef industry and to the beef products. Thank you.
The title of our work is to identify an unknown compound in sow's milk. In 1992, when I first came to work here, and I found a very, very abundant component in sow's milk. And this compound is so abundant. It's amazing to me. So over the past 26 years, I use many techniques to try to identify what a compound is. And it failed. But last year, I met a mass spectrometry specialist. And he said that, well, we can work together. We need mass spectrometry to identify the compound. So here I propose that we use a mass spectrometry and with our colleague in the geochemical laboratory. And if we identify what a compound is, that is so important. Why? Because we also found the compound is present in human milk and cow's milk. In many milk species we have determined. So something must be very important. And the infant formula for children is not complete. And therefore, we need to identify all the components, particularly so abundant component in the milk. So if we get it done, it'll be very important for neonatal growth, development. Thank you.
Okay, so my name is Maria Esteve Gasset. I'm from the vet school. I'm in the Department of Veterinary Pathobiology. And I'm presenting a project that I had in my head for a long time, but I really need to collaborate with people that have experience in microneedles or ways to deliver drugs subcutaneously. So I'm thinking biomedical engineering or material science, something of that nature. And I also like to collaborate with someone that had experience in skin immunity. I work with tick-borne infectious diseases, primarily Lyme disease, but I believe this could be applied to many different pathogens that are transmitted through ticks, maybe even mosquitoes. And it's to deliver, to apply the vaccines topically. So if you look at the mouth parts of the tick, they're tiny. And it doesn't matter, we have many different types of ticks and we classify them based on whether their mouth parts are big or small, but still they're very small. And they won't go beyond the dermis. They will not inject their pathogens intramuscularly, they will not inject them in the bloodstream, they will inject them in the dermis, and then they will spread from there. So my hypothesis is that if we target that part of the immune system, we will be able to block the pathogens before they get to the blood and they spread, right? And that way we will not need to have super high antibody levels or super high numbers of dendritic cell or immune cells ready to go. With some of them, we will be able to control those pathogens. So it's a brand new idea. Skin vaccines and skin medication has been in the field for many years, but applied to Lyme disease in particular and tick-borne diseases is quite new. Nobody's done it. So I think we have a lot of potential. We do have a candidate, a vaccine candidate that has been proven protective when we use it in regular immunization. So I think that could be a very promising project that will hopefully provide a broadly protective vaccine against Lyme disease. That's it.
Thank you.
Good afternoon, everyone. Thank you. My name is Wei Ling He. I'm from architecture, and this is my project. So the objective of the project is to tackle this unresolved but critical issue of plastic recycling. I'm an architect, I'm a designer, so I've done researches and designs with recycled plastic for a while, for a few years, designing light fixtures, art installations, canopies. But without the help of scientists and researchers, I find myself always in this kind of situation, which is just intuitive exploration and just as an artistic expression. So I'm calling for collaborations from material research and evaluation research. So for the material research, I'm envisioning options and not limited to the options. So can be some research about recycling plastic and make portable recycling system, make it domestically useful and inexpensive to make, and can produce 3D printing filaments. And could also research on really looking into the molecular structure of plastic so that we're creating a new material based on the waste plastic. And the new material can have interesting features like being able to absorb solar energy or changing porosity or transparency based on the environment. So I'm open to all these new researches in material research. And the evaluation research would help me design and define the context of the design, because the design cannot be just by itself. It needs a context and also needs evaluation. So for the evaluation research, I'm looking for education, business, or industrial distribution, or anything that you can think of to recommend. So as a team, I hope we can work together to really make an impact on plastic recycling. Thank you.
Good afternoon. My name is Vinayak. I'm from the Department of Mechanical Engineering, and for all intents and purposes, I'm actually a computer scientist. So I work in the area of geometric modeling and human-computer interactions. And the project that I'm looking collaborators for, so our castles in the air. So we want to sort of enable spatial reasoning in children. That's the broader theme of the project, where we want to see how we can use virtual reality in combination with tangible user interfaces to promote this idea of physicality when kids think about shapes. Right? That's the goal of this project. So I'll be, so my area of research is basically, it falls under the augmented and virtual reality aspects of the work. But what I'm really interested in finding out is how do we evaluate these kinds of systems in relation to how children learn about shapes. So we are going to look at parametric shapes, simple things like cones, cylinders, spheres. Can we create a universal controller which a child can actually use? Right? What you find these days, like HTC Vive, these controllers are basically fancy mouse without the scroll. Right? So can we really think about a universal controller and then implement that to promote these kinds of spatial reasoning in children? So I'm looking for people who have some experience with child psychology or spatial reasoning who can contribute towards understanding the evaluation methodologies for this kind of research. And another interesting outcome of this research that I'm trying to look at is how to physically realize what children have in their mind through something like rapid prototyping or 3D printing. So I'm also looking for contributors who could bring in the aspect of physical realization into this project. Thank you.
Now, I never write things down, but for 2 minutes I decided I'm going to write this down so I can get it all in and tell you about my work. Change of pace, we're going to talk about menopausal hot flashes. And for a long period of time, as women experience them, we've assumed that they're benign. There's nothing to them. They just happen. They're part of change of life, and they're inconvenient. However, emerging evidence is telling us hot flashes are associated with cognitive decline and cardiac disease. So I think it's important we learn how to manage them and learn how to work with them without necessarily hormone replacement, which has its own issues. This model is a model I've been working on in looking at the hot flash, and it builds on some of the work a professor did on the neuroprotective effects of estrogen. What estrogen does in the brain is it upregulates, when the brain is active, like right now, it upregulates glucose metabolism, and glucose transporter 1 is increased by estrogen, facilitating the transport of the glucose into the brain, because the brain isn't fat, it doesn't store glucose. When a woman is going through menopause, she's losing her estrogen, estradiol specifically, and so she can't upregulate as quickly. And so the body's overcompensating and creating this hot flash to increase blood flow to the brain. That's the whole model that's up there. There is also some really clear evidence now using PET scanning technology that there are changes in the glucose metabolism as a consequence of the hot flashes. So it's worthwhile to continue to study this. I did do one NIH-funded study, and we found that hot flashes were inversely related to blood glucose. And when your blood glucose was above 100, this was a well-controlled study I did at the University of Michigan. When your blood glucose was over 100, you didn't have hot flashes. Less than 100, you were more likely to have them. So what I'd like to do in this next step study is several projects. I would like to work with someone who's good with cognitive assessment, because what we need to do is find a way to stimulate the brain through a cognitive activity so that it will elicit hot flashes. I need to be able to do that so that we could then have women stimulate hot flashes and also have them when they're not having a hot flash, so that we could scan the brain and see the differences in the activity and metabolism of the glucose. And the other thing we need to do is be able to assess the changes of cognition over time in a sensitive way.
Thank you.
So I teach at the A&M's Law School, which is up in Fort Worth. My area of expertise is in immigration law, and I work with students in an immigration clinic where they work on real cases. I also have a degree in public health. So my interest is in actually looking at how the changes in our immigration policies have affected the mental and physical health of immigrants, particularly in the US-Mexico border region. I'm looking for collaborators in the health sciences and public health or the med school possibly to help study some of these effects. There have been very few studies actually done on this, but some of the studies suggest things like lower birth weights for women after sort of an immigration crackdown that has terrorized a city. But there hasn't been a lot of findings regarding mental health changes. So it's something that I'd like to explore both quantitatively and qualitatively. So that's it.
Thank you.
Hi, I'm Chris Nowatarski from Atmospheric Sciences. So mainly I do a lot of severe thunderstorm research and tornadoes. So to motivate this project, I want to ask you guys a question. How many of you knew we were under a tornado warning during Hurricane Harvey? For part of that? One, all right. Since you knew, did you do anything differently? No, right? Okay, so there's the motivation right there. There's a lot of hurricanes and landfalling tropical cyclones, yet the public is often unaware of it because of the saturation of weather information during those time periods. People are worried about high winds and storm surge, but especially inland in an area like here, tornadoes can pose a big risk. Another problem with this, though, is that the forecast offices that are issuing these tornado warnings are overloaded with work at the time. In Galveston, the Houston-Galveston office, they're more worried about other pressing issues in Houston, essentially. So what I'm interested in is both improving the quality of the forecast, that is reducing the false alarms of the forecast, essentially, so that's the more scientific side, at least in terms of hard science, but also interested in the sociological component of how do people interpret these warnings, what do they do with the information when they get it, if they do anything, and how can we improve the effectiveness of the warnings if they're successful. So I really am interested in collaborating with both social scientists as well as statisticians to improve our statistical methodology in forecasting, essentially, these specific risks. So Harvey is one hurricane we would look at in this case, but there's also been a lot of recent hurricanes, especially since we've had some updates in the radar observing network. So there's a lot of useful data out there that has basically been unmined that we can pull a lot of more information of. I'm interested in looking at both radar and numerical model predictions and developing a statistical model based off that data, but also then bringing in a social science component to really interview the forecasters in terms of what's their process in decision making and issuing these warnings to improve the forecasting side, but also interested in how does the public, what does the public do with this information?
Thank you.
Good afternoon. I'm Rodrigo Bombardia. I'm an assistant professor at geography. And this here is work I did before. So I detect the onset date and the end date of the rainy season for monsoon regions. And then we look at how predictable those dates are, because they could be important for water resource management, for farming, right? And we find that they are predictable up to a month in advance. So that was encouraging. For this tea tree initiative, though, the idea is to take something new. So I was thinking to apply the same methodology or similar methodology to the growing season. So to detect the onset date or the ending date of the growing season. And for that, I would love to collaborate with people in agricultural studies. I'm also always had an interest in evaluating predictions from a perspective of economics. So if people would follow those predictions, would that benefit society? Would we save money, be more efficient, and so on? So I think this is my speech.
Okay,
Yeah.
thank you.
Yeah, howdy. Yeah, how many of you have called, someone who has a phone, and then instead of hearing the typical, ring, ring, ring sound, you heard a song or message? Yeah, that song or message is what is called caller tunes, okay? That is different from what we call the ringtones. For ringtones, it is you, who hear it. It's like when I have a phone and someone calls me, the sound that I hear, that one is a ringtone, okay? But if I call somebody, before the person picks the call, the song I will hear, the caller here, is the caller tune. It's a common phenomenon in sub-Saharan Africa, especially Ghana. But we have not used it to address public health issues. So the goal for this project is to design a caller tune that is going to focus more on drug safety reporting. So if I call somebody and that person has that caller tune, I could hear something like, if you take a medicine and you have side effects, report to this center. And the reason why this is important is that drug safety reporting hasn't been taken seriously, particularly by patients in low and middle income countries. And as people take more medicines, we need information on them so that we can profile them and make decisions. So I'm in the School of Public Health, and my research looks at how we can use communication to address global health issues. I happen to be a pharmacist. I'm also a science journalist. And so I look at how we can use communication to address issues. So in this case, I'm looking for collaborations from those in medicine, pharmacy, nursing, stuff like that. So thank you so much.